Hi everyone, here we have a two-part question. In part one, we are given that y equals the square root of 4x plus 1 all cubed. We want to find the derivative, dy dx. In part two, we want to find the approximate increase in y as x increases from 6 to 6 plus p, where p is small. Let's start by writing the function in index form. So we have y equals 4x plus 1 to 3 on 2. We can use the chain rule to find the derivative. So that's dy dx equals dy du times du dx. So we'll let the inner function equal u. So u equals 4x plus 1. Du dx equals 4. Therefore, y equals u to the power 3 on 2. So dy du equals 3 on 2 u. 3 on 2 minus 1 is a half. And replacing u with 4x plus 1, we'll have 3 on 2 square root 4x plus 1. So dy dx is dy du, which is 3 on 2 times the square root of 4x plus 1, times du dx, which was 4. And that will give us 6 times the square root of 4x plus 1. And that's our gradient function. For part two, we'll use what we can call the small changes formula to find the solution. So delta y, delta x is approximately equal to dy dx when delta x is small. Let's rearrange the formula. We'll have delta y is approximately equal to delta x times dy dx. And we're going to evaluate this derivative at x equals 6, which is written in the question. And from the question, we can also see that the change in x, delta x, is going to be p. That will give us delta y equals delta x, which is p, times dy dx when x equals 6. So we'll have 6 times the square root of 4 times 6 plus 1. That will give us 6p times 4 times 6, 24, plus 1, 25. And the square root of 25 will be 5. So when x increases from 6 to 6 plus p, the approximate change in y will be 30p. This is your final answer. Thanks for watching.